Hi, today we're going to learn about friction and its coefficient. What is friction? It is the force that resists motion. Sometimes we want it and sometimes we don't. We know that it varies based on the surface it's in contact with, and it varies based on how smooth it is and also how much the two surfaces adhere to each other. Now, as you know, you need friction when you're walking for grip, and sometimes you want to reduce the friction so you want to move faster, like say when you're ice skating or so. Now, in this lesson, what I'm going to do is show you how to measure the coefficient of friction on a flat surface. So specifically, it's going to be the coefficient of static friction. So before we begin, I want to show you a couple terminology. So one is, you can see this diagram. Here's a flat surface and here's a block. The weight of the block is acting downwards and the normal direction is acting upwards. And the direction of force applied is this direction. So hence the frictional force represented Fr is acting in this direction. Now as we pull, the frictional force is going to oppose the movement. So how do we calculate it? So here's an equation for that. So frictional force is equal to mu s times the normal force, which is mg in this case. So mu s is called coefficient of static friction. So let's look at the forces here. We have the frictional force represented by Fr, and the force that is being pulled by is F. So if the frictional force is greater than Fr, the block is not going to move. That means it's just going to stay where it is. And as soon as you increase this force, when the frictional force is equal to the force that's being applied, it will barely begin to move. And at that moment, we can take that force being applied as the frictional force. So here I have a 1 kilogram weight, and we can measure this in the scale here. So you can see it. So this is a weight of 1 kilogram. So what I'm going to do is I'm going to drag this along two surfaces. So now we have this weight on this green cloth. I'm going to measure how much force is it going to take to get this barely moving. So we know that that is the amount of friction force that is resisting its motion. So let's have a look. You can see the scale. Right now it's 0. As I pull it along, it's increasing. It's about 200 grams, but it's not moving. 300 grams, not moving, and can keep going. So around 400 grams it moves. So once again, okay, take a look at the scale. Yeah, it's about 400 grams it starts to move. Now let me measure the same thing on the wooden surface. Okay, once again, have a look at the scale. So it's moving around somewhere around 200 grams, maybe a little over. Let's do it again. Yeah, around 200 grams of force when I'm applying, it's begin to move. So we could take that is the frictional force that is resisting on the wooden surface. So now let's do the calculations, and I'll show you how to derive the coefficient of static friction. That's what it is more specifically known, and I'll show you how to calculate that for these two surfaces. So we just measured what is the force that is requiring to move the block over green cloth and the wooden surface. Now from there we're going to calculate the coefficient of friction on these two surfaces. So let us use the the frictional force what we found on the green cloth is 400 grams, which is I'm going to represent as 0.4 kilograms times the g, the gravitation force. Now this I'm going to substitute with this equation, which is going to be 0.4 times g is equal to the coefficient of friction, static friction, multiplied by the mass, which is 1 kilogram, times the g. Now with this, mu is equal to 0.4 times g divided by 1 times g, which is equal to 0.4. Alright, let's do the same method to calculate the coefficient of friction on the wooden surface. So the force that was required to overcome the friction was 200 grams, which I'm going to say 0.2 kilogram times g. So this is, remember, this is the force that required to move it on the surface. That means when it barely begins to move, the frictional force is equal to the force applied. That's why we got this equation. And so we're going to substitute this value to here, where the mu is mu of the wooden surface, okay, times the mass of the block, which is 1 kilogram, times g. So with this, mu of wooden surface is equal to 0.2 times g divided by 1 times g, which is the coefficient of friction on the wooden surface is 0.2 there. Now you can see this is about half of what we found on the green cloth. So there you have it. So with this method, you can pretty much calculate the coefficient of friction on any flat surface for that matter and find out what it is.